How is everybody's Thursday going? Don't all answer at once.
Pretty good, pretty good.
Hey there, Derek.
Hello.
There at least one of the ones on here. Might be good to get somebody that's goes way back in the spec to give some thoughts on it. I was looking at the Go Digest and I did a little bit of a rewrite on my own side, just playing around with how it would work. And one thing I came across was looking at how well we would support a digest encoding that's not hex. Like it's in the spec that we support it, but Go Digest just throughout there, it's just assumed that it's going to be hex.
Not supported well, I would say.
Yeah.
I mean, there's no way to or there's not a good way to decide what the encoding is based solely on the type there. So I don't know better way we'd want to stringify it. We're trying to suggest like base 64 or something.
Yeah. I was looking at trying to decide, do I want to try to answer this question now or kick it down the road the way we've been doing it before?
What is the motivation for doing something not hex?
My suspicion is that there are hash encodings out there today that might be more common to encode their stuff, encode the string of the hash in whatever format they're already using within that encoding.
I mean, I think once you start get to longer outputs than 256, then maybe that becomes relevant because the hex strings just get ridiculously long. But yeah, I don't know that if that's really the direction we want to move in anyways.
Yeah. I mean, I'll throw an example there. Rom, take for example Blake 3. If everybody that was implementing Blake 3 implemented with a base 64 encoding instead of a hash encoding or hex encoding, would we want to adopt the base 64 for the encoding of the string?
Possibly, but in general, I think hex encoding is the predominant format, I think, and I don't see that changing until maybe something like quantum crypto comes in and says we need much longer strings. Until then, I think we can just run with what we have.
Unicode encoded emojis or something. At that point, they're pretty long.
We do have a character set in there that restricts it.
That's no fun. Right?
I know, but I was trying to restrict it even worse, and then I realized, oh no, I can't do that. We allow A to Z, lowercase, uppercase, numbers 0 to 9, equal underscore dash. Does that get us base 64, or does base 64 need other characters like slashes and stuff?
It depends on your definition of or which base 64 encoding you're using. That's why we mostly stuck away from base 64 because there's different opinions over what those extra couple characters are.
Got it.
Yeah, this is just, I think, mostly a discussion about novelties, not very useful.
So for me, I was looking through there and trying to decide, do I want to solve this problem that Go Digest has kicked down the road?
I don't think you do.
Because as we were talking last week, Rom, is you got me to look at how it worked to re-implement Go Digest without panics in it. So that was my week this past week.
Fun stuff. Okay.
All right. Well, the other one that was on the agenda was concurrent upload support. Do we even need that? guess we can kick this thing off officially. We kind of pseudo kicked it off. Yeah. So we've got 3 different issues over on GitHub saying, hey, we need to support concurrent uploads. And I'm just throwing the question out there because I think Jeff has asked it in a few times, and I think it's a good question to ask of, is this a problem we actually need to solve? I know it would speed up uploads, but in the grand scheme of everything that's going on with people pushing things up to a registry, that's not where most of the time is spent.
I think I agree with Jeff on this one. I don't see any evidence that this needs to be solved, but it's an opinion, which I will change if I see evidence.
So I ran some numbers on upload speeds on like a 100 gig file on S3 versus OCI registry. And the uploads are at least double, if not more, in terms of time. Like it took 15 minutes to upload to S3, and it takes like 40 minutes close to upload to OCI because of the extra overhead. 15 minutes is fine for people. 40 minutes is too much, I feel like.
So when you say OCI, you mean OCI backed by S3? Some OCI
Yes,
registry backed by S3.
Exactly, yes. Yeah, eventually it's going through S3, but S3 it's going via multi-part upload, whereas with OCI it goes through sequentially.
I feel like if it's taking 15 minutes, you've already gone away to take a coffee break, wait for the recompile to finish, start up a sword fight with the coworkers in the office.
Yeah, but it's like 3x I feel like 3x slower is not that great.
Is that it's per layer, right? So like, do you just have really big singular layers? Like,
That is correct.
it
Yes.
just feels like you need a better build process to more efficiently break apart your image. That way you can reuse content addressable storage.
Oh, it's not it's not a regular image layer. It's just an artifact, like an AI model, 100 gig. Like think of just a random 100 gig.
Oh yeah.
Like, out of curiosity, how quickly do those change though? Like, I mean, I know here at Docker we're doing the same thing. Like, we are pushing up very large models, and yes, they do take a little bit of time. But like, unlike image processes where people very frequently will push up a new image with every Git commit or something. I mean, you're pushing up, tens of times, hundreds of times an hour just with every CI build. Like, I have not seen that yet with like AI. So I mean, I think those are we're probably seeing those like one upload a day kind of a thing, like not necessarily on a very rapid CI process.
Yeah, I mean, yeah, I agree with the amount of like frequency of downloads is going to be always be more than uploads. But the fact that like it takes 3x time is just preventing people from just using OCI because they can say it's so slow. Why would I even go? Like it's just preventing a group of people from just not using it.
Is the content of the layer of the model, I don't know how models are constructed. Is it a reliable sizing, like a Parquet file, where you could attempt to chunk the model because you know that there are certain at a certain byte range, it's going to be it's going to be reproducible. Is that a possibility for when models are built, or is that not?
What do you mean reproduce? Like, can you expand on
So
that?
like yeah, with the model blob, right? How it's written to disk, is that ordered? Is there like a certain part of the model that will always be the first 100 bytes or first gigabyte, or is that randomized? Is it just like a freshly compiled thing every single time?
Yeah, from what I've seen, it's mostly random. There's not a good way to break the model in such a way that you can, like how you do it with layers, I don't think you can do that right now with AI models.
Because I'm just feeling that would, if there was a way to do that, that would be the better solution than refiguring out a lot of different networking strategies for the S3 backend. Because also at the end of the day, you're going to be constricted by your network pipe. You can make your uploads, concurrent uploads hyper efficient, but if you don't have a good network pipe, it's all kind of moot anyways.
Part of that's why I was picking on the 15 minutes, because 15 minutes is a really long time for an upload to happen anyway. So once you've waited that long, what's waiting another 30?
Yeah, but it's also a 100 gig file. So so the thing with the singular uploads is you're limited by the TCP window size, right? So that is the amount of data that can be in flight at one time on a TCP connection. And there is a limit to that. That's why a lot of people see when they distribute the upload to multiple connections, it increases the throughput. Sanjay?
Hey, Sid, sorry if I'm pronouncing your name wrong. I wanted to get a sense of, I think the statement that there's a lot of pulls versus pushes kind of disregards an entirely different scenario, which is the inner loop of these kind of operations. How frequently do you see somebody, like when they build these things and train these things, push and then run it on a cluster? Is that ratio relatively smaller? Because I think that's where a lot of devs or people kind of using this kind of gets really turned off when, hey, this once I've done the initial phase, it's taking so long to push, and then I don't. Why do I have to wait for so long? Is the question, right?
Yes. So you're asking how frequently do people upload these kinds of large models?
Yeah, even in an inner loop scenario where you train the model, you push it, and then you run it on a cluster or something like that. Not before publishing. A publishing, as I understand, is like somebody like once they decide to put a model out, then it's very infrequent.
Yeah. Yeah, like we do publish. So in Red Hat, we have a team that publishes AI models, and they do it, I would say, like weekly. But the real use case here is the people who are going to use it to tune it. And I don't know how frequently they're going to upload. Like, think of Hugging Face right now. There are more than millions of models there. And I'm pretty sure they're not infrequently pushed. Like, they're probably being pushed every single day. So that's sort of the use case I'm looking at.
But when we're looking at that, how long does it take to do the training? You know, the training isn't going to happen in 5 to 10 minutes. That's a long process itself. And after they've done the training, do they have to push to a registry to do the testing, or can they just start testing right there with the local model, make sure everything looks good, and then once they're happy with it, then publish?
Yeah, I don't know how their workflow is, but yeah, like even in training, right, it goes in steps. So you might have intermediary models, or you like think of it this way, like the more let's say you have a training data set which comes in every month, or which comes in every day even. So you can think of like a model being updated every day even.
Yeah, I'm just trying to think of that inner loop. If the inner loop is that they're spending hours of time training, then doing all the local testing, however long it takes to push up to the registry may be peripheral to what their inner loop is.
So the surprising thing is like let's say you do in the initial AI model, like the training initial model might be very expensive and long, but incrementally training it, like adding new data set and changing weights, that's not that expensive.
So the question is, what about backends that don't support this kind of pipelining, right? So that's one question. The other one is, I mean, if you want to put this in the OCI spec, the other one is it possible to bypass the registry itself? Why does this have to go through the registry? I mean, you dump all your data somewhere fast and make an image and then expose a image manifest that can download now. So does the upload have to go through the registry, through the OCI interface?
I mean, no, it doesn't have to be. Like, you can upload on S3 and yeah, as you said, like just write a text file and saying, hey, this is where the model is. That is 100% viable approach.
This is bringing back nightmares of ref layers and remote layers. Please don't go there. We're trying to. I think it's. I mean, you could definitely do indirection and redirection. Remote URLs already supported and whatnot. So, but I think the point is, folks want to use OCI. We don't want to discount the scenario. And once it gets fragmented, it's very hard to bring it back into a good place.
Yeah, I think having it in OCI as a distribution is nice, but I don't think that necessarily needs to be part of the inner loop. People don't use that when they're doing normal container image development today. They do all the development locally on their machine, make sure it all works, and then once they're happy with that, then they push it up, commit their code, CI runs their CI stuff, and then at the end of that, it gets pushed up to the registry. So widespread disagreement, like we usually have.
I would even be happy if you just have the chunk uploads be parallelizable. I think that's one of the PR someone or issues someone opened. That is a relatively smaller change than like what I'm proposing, right? And are we even discussing that change? Like, is that change to parallelize the chunked uploads, is that too controversial as well?
I think the questions around that was less controversial and more the challenges, technically speaking, around compatibility of does it support it, does it not support it? Now we have to fall back, and there's just a lot of weird gotchas with it. And then you still have to like put it back together in the end and rehash it. So I don't.
So I think this is the one that Jeff's referring to, which is you got 3 different scenarios in that one to deal with, which is you got a client, you got a registry. They can be on different versions. One can be upgraded, one cannot be upgraded. And the only scenario where you can do the chunked upload concurrent chunks is that both the client and the registry need to be new, but you need to make sure whatever you do to support that doesn't break any of the other scenarios.
Seems like something we can communicate via HTTP headers, possibly.
Some kind of negotiation has to happen there, but it can't just be something in the spec saying, okay, from this point forward, we used to say that you must error out if you see something out of order. We need some kind of way the client can tell the server, hey, I'm going to try to do this. Will you allow it? And the server needs to respond back, yes, I allow it. You can do that. Because if either one of those is acting out of sync with the other one, you get the client pushing stuff out of order to an old registry and the registry just breaks entirely and then you don't get any upload at all.
Yep.
Or you
No.
get an old client that something went wrong in the middle of the upload and the registry is just allowing the contents to come up because it assumes the client's pushing stuff out of order. And then suddenly at the very end, it tells the client, oh, by the way, you didn't send me everything, you failed. After it finished up its 100 gig push.
And I would also say that not all digest algorithms may work with this, or I don't know.
So this one to say that you can do out of order chunked uploads didn't address the hash algorithm at all. And so the server is going to have to keep the entire upload at the very end and then restream the whole thing to do the digest verification.
Yeah, no, that's not. It's hard on registries to do that.
Which
I
is
would
why
say-
a lot of registries might just say, no, we don't support it.
Yeah. I would say only do this when some kind of a parallel hashing or out of order hashing algorithm is supported.
Yeah,
Jay?
we've got a few of those proposals. I'm not quite sure. I don't know we're all talking the same. I think some of us are. But then when I was looking at some of the stuff coming over from this one,
I think one thing to also, I mean, I think it's also important to consider with this is even if you do upload 100 GB blob, the fact that most registries will use a CDN to distribute that, like that blob is now too large to be handled by a CDN. Like, should that be a consideration at some point that maybe there is an upper limit to what we should work around?
Yes, that's a good point. And in my issue, I raised that as well. Most of the CDNs have a limit on how big of a file they can store. CDNs are also working on this because they have a problem themselves holding large files. The CDN we work with, they are trying to do like range requests. So instead of a 100 gig file, they only store like chunks of files. It's not ideal, so it doesn't really like solve the bigger issue of these large files. Most of them they just push back to origin, and they are stored from the origin, sort of completely bypassing the CDN. So that was one of my the proposal that I gave was just to chunk on the client side and have client side handle it based on like DM Verity or some kind of a chunking algorithm.
yeah, I had a hard time when I was reading this one to understand if this even really solved our issue. Because I think when we look at Blake 3 and I suspect some of the parallel hashing stuff, the process to enter the data into the hashing algorithm didn't have like a write at API call. It was just a write. So I think they were still assuming there was a sequential write into the hashing algorithm, and the hashing algorithm itself had some kind of way to do the internal chunking and parallelization at that point. But that goes back to you're doing the hash at the very end instead of as you're reading the data. Yeah, I mean, looking at this implementation, it just had writing block hashes. So you would write a slice of hashes, but I'm not clear. Maybe this was just only a partial implementation, there will be another layer above this that would have to keep track of the individual blocks. But I'm looking for more like a write at function where you just say, I'm doing a write at this offset, this many bytes. And the hash algorithm will keep track of, okay, is that something new I haven't seen? Let me hash that. Does the S3 API do well with concurrency in terms of you have multiple concurrent writers at different offsets? Is that, I haven't looked at the S3 API to see, is that something that they handle just fine?
Yeah, you can upload in any order you want.
Concurrently, not like,
Concurrently, yes.
okay. So I'm thinking even if I was to write this into a native file system, I need to make sure the OS calls to write that I don't need to lock the calls to write and make sure I'm writing one chunk and then another chunk and then another chunk each individually, that I can do it concurrently.
I'm pretty sure in S3 as well, they don't collate the whole file, the whole blob together. They just store the parts of chunks, and then as requests come in, they just serve data. So that's why they can just go at it.
How do they handle knowing I'm serving a request for a chunk of a file that was never uploaded? Like, do they keep track as you're uploading that you were sequential across the entire file?
You got to keep that on your side. So when you're uploading, you have to say this chunk is from this offset and it's this size.
But if you finish the whole file and you left a big gap in the middle, they just give you zeros.
No. So what's going to happen? So when you upload all the chunks, then there's like a commit API. So there's something called as complete multi-part upload API. So when you upload all the chunks, you call this complete multi-part upload with the list of all the chunks and their addresses. And then when S3 says you're good, then that is considered a full upload. So in my case, when I said like it takes 14 minutes, so it takes 14 minutes to upload all the blocks and about 200 milliseconds to call that API for a complete multi-part. So once that is done, that is when you consider everything has been uploaded. So yeah, you cannot leave gaps in like you can upload as in any order you want, and at the end you just commit with the list, and then S3 verifies that list and says you're good.
Yeah, I'm thinking the registry would want to keep track of those gaps and make sure there are no gaps in the final before it calls the stuff to the backend S3, just in case it's not backed by S3.
Yeah. Yeah, in this case, S3 doesn't keep track, like it's the client's responsibility to keep track of all the chunks.
All right, I only threw 2 items on the agenda today. More than happy to keep chatting about this. I kind of got as much as I thought I was going to get out of the digest encodings other than hex. So if folks want to keep chatting about this, that's cool. If you want to add other items to the agenda, that's cool too.
Yeah, so I was playing a little bit with Blake 3 and OCI images, so maybe I can show a small demo of at least the work.
Go for it.
So this is just the basic Docker file, and I have to do it from scratch because I don't have any from that can do Blake 3, right? So all this does is just gives me a shell using BusyBox and a very quick way to create a 0 file and a 10 gig 0 file somewhere in the container, right? So And in this we have, so the conversion of that in the stacker world. Stacker is the tool that I'm using. It's fundamentally that. So if I did which takes that stacker.yaml by default. So the truncate is fast because it's a 0 file, but the rest is, it is creating a tar.gz plus the SHA-256 hash. This is going to take a few minutes just to show how long it takes.
While we're waiting, you might want to bump the font up a couple.
Sorry, Mike, you said
Like-
something?
I was saying while we're waiting, you might want to bump the font up a couple notches. Make it a little bigger.
Yeah. Okay.
Yeah, that looks good. App art doesn't look happy, but everything else looks good.
Yeah, this is just to show how long it takes.
In this case, the Blake 3 is happening.
No, this
on an-
is still SHA-256, not Blake 3
Okay.
yet.
Either way, the algorithm you're running in this case, in this scenario, isn't streaming as something's going in. You've finished completing the entire blob, and then you're passing
Yes.
that entire blob at one
Correct.
point.
That's
to the
correct.
output. Okay. Because depending on the tool, if it's something that happens over time, they might defer the digest calculation until after the blob has been uploaded. And so they can stream the calculation simultaneous with the generation of it. Or
That's, yeah.
to phrase it better, they can parallelize the pushing of the blob to the registry with the computation of the digest.
And this should be done. It takes about a minute. Maybe I should have taken a smaller file, but let's see. We're already there. Okay, so that took that long, roughly. And so let me go ahead and clean this as well. And let me take, so I'm going to do this with B3, which is the, okay, so before that, yeah, so that should have created the, should have shown you the output of it, but that creates an OCI image in an OCI layout with the usual stuff. But this is with the same thing built with Blake 3 support. Okay, there you go. So that was with Blake 3. So before I clean it, let's see. Next JSON. So it says the manifest that got pushed for the image that got created is Blake 3. And then and all the layers, it is just one layer. Everything goes to Blake 3, so on and so forth. So, and of course, Stacker also does, this is just an additional thing. It also does things like HeroFS and things like that. But it's a discussion for another day for the container debug. Yeah, 10 gig file with HeroFS, not so sure. Okay, so that's all I had. I mean, basically, this is the multi-hash, the different hash types, and it looks possible to build images using Blake 3 like so. That's just all I wanted to show. And it is very fast.
Is it fast because you're parallelizing the
No, just Blake 3.
Oh, it's just like 3.
Just calling into Blake 3. That's it. I'm not doing anything special there.
Is it using
Blake-
multiple cores or it's still single core Blake
I
3?
think it is single threaded. The implement. This is just the Go Digest Blake 3, which is supposedly single threaded, but Blake 3 construction itself is parallel, so it can do things, I guess.
I read somewhere, I don't know where, someone was telling about the cryptographic security of Blake 3 versus SHA-256. Is that a concern at all, or like is Blake 3 fine as a replacement for SHA-256?
So when you talk about hash digest security, there are a couple of things, right? One is how the one-way hashness. So if you take a particular hash, if you invert it, will it give a collision? So that is one issue. The second issue is, can you use this hash algorithm to create something like a keyed HMAX and this kind of things, right? So so these are actually different topics. So in terms of the pre-merge resistance, I think Blake 3 is pretty good. And I think the authors would argue that it is pretty good even for HMAC, but that I'm not so sure about.
I had a quick question about conditional tagging and conditional manifest pushing. So from what I can see, the only time that it's really referenced in the spec is when it is the refers API. Other than that, I was trying to, but even with the sorry, the refers API says that if you want to prevent mid-air collisions, you need to leverage eTag. And I looked at that portion of the spec and I read through distribution to see if it was implemented, and I didn't see it there for the put request on manifests. I was just wondering, is that something that we would want to add to the spec, or is that something that is out of scope for what a registry should do? Because I'm trying to implement OCI registry as a storage mechanism for open tofu state and implementing a locking mechanism. But the only way to really do that is if you need to prevent mid-air collisions for updating a manifest or an OCI resource. And I didn't see that in the spec.
Not in the spec because we chatted about it way back in 2021 and never got to the point of approving a PR on it. We definitely chatted about it, and it's kind of the direction I think we're leaning is saying, let's do this, but let's defer back. Pony until 1.2. Some of the conversations in here went into do all the backends support it? And then if the backend doesn't support, then potentially you couldn't do it in the registry because the registry would be backed by something like a eventually consistent database of some kind. But in the cases that the backend does support it, we'd like to, I think the idea here is we think this is a good idea. In fact, he did a PR on that.
Gotcha. So if you were running your own custom implementation of the registry spec, this is something that would be part of the spec.
We'd like to have it in the spec, and it's in the HTTP specs. So theoretically, we're on top of HTTP, and so you can just defer to that. But yeah, we were chatting about way back in 2021. I think all the details here are just going back to, IETF references. Because it is something that I think there are a few people that like to see this. It would solve some interesting problems.
Hmm. Yeah, it would prevent certain types of parallel tag mutations from happening, where basically just like last person wins.
Yeah,
That's the only
especially
thing really holding back my implementation.
I'm thinking on the scenario people doing like a multi-platform upload of an image, and they keep pushing individual platforms, and they don't know if all the platforms have been there, and so they pull the index, add theirs, and push it back up there, but they don't know they might have a race condition. So yeah, that sort of thing makes a lot of sense.
Hmm. So yeah, as well for refers, if you wanted to prevent uploading the same refers twice, the refers API tech right now does not have a guard really against that. Like the guard is fetch the current refers, but then if you, because distribution doesn't support the refers API, you have to use the fallback. Fallback is just, it's just a tag. So there's no prevention of a race condition there currently.
Yeah, and I don't think we are going to be able to do that just because the fallback or refers is assuming a registry that doesn't have newer features.
Hmm.
And so the fix for refers is going to be support the refers API, and the registry does the eventually consistent and handles everything for you. But in the case where they're doing the fallback, it's good if the registry supports it, you can attempt it. But if they don't, what are you going to do? You just,
Yeah,
you're stuck with a race.
I would not even support the fallback at that point.
Yeah. But in
Alright, cool.
general, I think there's a lot of interest in that. And so if you want to chime in, follow that issue, work on some implementations that support it, that would be interesting.
Yeah, I have a POC for at least client side how it could work. But I'll push up and link into the thread.
Yeah, I think we also need to, at some point in that issue, work on, where did I leave that over here? Yeah, it's just changing spec stuff. There's no conformance test for it. So that would be another thing to work on adding. A lot of this gets into how we want to delegate more into upstream RFCs. And it might get into, do we want to try to reformat the spec a little bit to just say, look, we are based on top of these upstream RFCs. We're not going to rewrite them over here. Just have some kind of reference of saying, for e-tag support, see here. For, a redirect support, see over here. All the different HTTP RFCs that we depend on, just have all those pointers. That way we don't have to rewrite all those.
You'd have to make sure though that you support every single aspect of that RFC though, which I'm sure is not a small undertaking.
If not every aspect, to call out what aspects within an RFC we support. So that kind of gets in, distribution spec was like that a lot, where we were pointing out that, oh, I need to find the specific example. We had a bunch of those in distribution spec where we had a whole bunch of pointers to one subsection, and then within that subsection, there was disagreement. Because some people thought it meant the entire, and some people thought it meant just that bit. I'm blanking on the specific piece, and so I got to go find it again. It might have been the media types. I think it was the media types I'm thinking of. We were linking into the media type specification and saying, here's how we support that. But media types can have parameters added to the end of the base media type, whether it's like UTF-8 or version number or something else in there. And there's been a lot of disagreement of whether or not we want to support parameters on the media type.
Gotcha.
And we had specifically linked into the subsection, but we didn't say, okay, just that subsection. And so you're right, we do need to be specific when we do something like that. All right, with the last couple minutes left here, we found my other window. I was playing around with rewriting the Go Digest in a slightly different format. Where did my mouse pointer go? There it went. Weird, when I'm sharing, I don't have my mouse pointer over here. So I'm just gonna have to go with the keyboard. Yeah, but the only thing I really wanted to point out was I was doing a register algorithm where I just registered using the name of it and a function that would generate a hash, which means that my register commands can look like this. And if you need me to, I can bump the size up a bit on that. It basically means that I just pass the SHA-256.new function in there and say, here's the function that can generate a new hash of that thing. And that felt like an easier way to do the register than what we're doing right now in the Go Digest, which since that hasn't been tagged and released, I think there's still time to make adjustments over there, but just kind of want to have some thoughts there on that one.
Yeah, I mean, I think that's a much more sensible interface from my perspective.
Because then in here, I'm able to pull the size out of the hash. I can call that new function, extract the size from it, and then my algorithm just has the name, size of the new function, and that gets registered. But the reason I was asking in the beginning of the meeting about the encoding is because I was starting to think about that. Do I need to register the encoding algorithm as well? And that gets more complicated.
And I don't think that available check is really that useful, where it's like you have something registered, but it's not imported.
I think the only way that made sense was the SHA-256 and 512 before you started importing it for us.
Should we conditionally import those, or are we already importing those? Oh, I guess we have to import it by calling, like by importing or by registering the new, we've imported it already.
Yeah, you are doing it now, but I'm wondering if there was a point in time in history where you weren't, and so you needed that.
There
Yeah, for
was
me,
definitely a time in history where, like, yeah, you'd get panics from like not if you didn't explicit or like import SHA-256 somewhere.
Yeah, I'm going through all this and just doing errors on this. And then the process I was looking at was making algorithm instead of a string. I'm just making a struct with unexported fields in it, non-public fields. And so you have to go through and call the lookup or one of the other functions in there to get an algorithm back out of it, so that I know those fields are always set unless you use an undefined, basically a new variable without defining anything in there, and that does have checks and has return errors from those. So I'm playing with this. This is just sitting in my own repo right now. This was my last week of writing a little bit of code. Similar on the digest side, instead of making it a string, I've got an algorithm and a hex, but now maybe hex shouldn't be hex, maybe it should be encoded. Because I was trying to make a regex for the encoding and then realized I can't do that. Because the encoding is actually all of this.
Yeah, I mean, you could have a version of the register that takes an encoder, decoder, but I'm just, yeah, I'm not sure we need that right now.
It's one of those where if we want it someday in the future, it's a lot easier to add the capability now than it is to rewrite the functions later. If
Well, I'm
rewriting
just
it.
saying, I would think you would have another custom version of that, like algorithm register. So the default is going to be hex, but if you want one that's non-hex, you could add another interface there. Because we already renamed the hex ones to encode, right? There used to be a function that was .hex or whatever, the digest hex, and then we call it encoded now. So there was some thought of at least not making that opinionated at some point, clearly.
So are you asking
At the very
algorithm or
bottom of the
digest?
digest.go.
Because in here, it's just a string, and then you've got the functions to extract it from there. But you call algorithm encode to get
Yeah,
it.
but go to the bottom. It's saying that it used to be called, digest.hex.
Yeah.
And then that was renamed to
encode.
digest encoded.
Yeah.
Even though hex just returns encoded, but in theory, that digest value could have other encodings.
Mm-hmm. Could, but we don't do it yet.
I mean, I think if we did it, you'd have to register it as like a SHA-256 something B64 or something like that. But
With like the plus syntax or whatever we've got in there, we've got a few of those.
I think you'd have to, otherwise it's too messy to try to guess the encoding based on the string value or
like
the
that
string
saying.
length,
Yeah.
which is so ugly.
That would be an option. We could have base 58.
Oh man. Yeah.
Hey, I didn't write this stuff.
Hey, I didn't accuse you. I'm just saying, oh man. What's that?
I'm in violent agreement with the old man sentiment there. All right, that was all I had. Figured I would just share that there is some hacking going on my side as well, which completely distracted me from working on my authentication stuff, which completely just distracted me from working on the conformance test, but we'll get there eventually. I'm easily distracted by shiny new things to look at. All right, you're all being quiet. We've run out of topics, I think. Any last request, or should we wrap this thing up? I'm here and wrap this thing up. So let's call it for the week. And yeah, appreciate the conversation. Keep it going over in the Slack and see you again next week.
Thank you.
Later.
Cheers.
Bye.